So many of you know about nanoHUB and some of the efforts that we've had over the years related to analytics and understanding the impact of the hub and how, in many cases, these methods have been transferred to other hubs as well. And I think this morning we have an opportunity to hear about another one of those potentials. A couple of years ago, we got engaged with Kati Borner from IU, who will go through this morning in more detail this particular project. But as we look at measuring impact of our research environments or our hubs, certainly one of the things that helps us demonstrate that impact is how people in our networks are publishing and what their interrelationships are. And the stronger this network is, the more interesting I think some of the topics are that are being researched. And Kati's been in this field for a really long time now and has a huge amount of expertise at this. And so we were very lucky at nanoHUB to be able to have a partnership with her to take some of the work that her group has been doing for many years and incorporate it into some of the work that our group has been doing for many years and sort of put the two together. And our initial demonstration on that is with the nanoHUB. Although the intended user base of this capability is not just nanoHUB users. It was sponsored by the NSF to initially to help their large engineering research centers be able to more accurately or more pictorially depict their impact and research interrelationships. And so all of these folks are being encouraged to use this capability on nanoHUB. But I think what I would like for the folks out there that are running hubs to consider in this is the level of interest you would have in having this same sort of capability available in your hubs. It should be a fairly easy thing to translate, and we think it's a real interesting facility, and it also sort of goes along with some of the strategies we've been pursuing at HUBzero in terms of incorporating other types of web applications into the hubs that go beyond just the traditional tools that you all have seen several times now. So with that, I'd like to turn it over to Kati and her team to talk a little bit more about what this capability is doing on nanoHUB. But I would also encourage you to think about generically demonstrating research networks within your own domain, maybe like it's presented today with literature cited publications, or it may be many other ways that you might want to demonstrate the same sort of network capability. So I'd like you to think about it from the perspective of perhaps many different ways this same facility might be used. So with that, Kati, take it away.
Thank you, Mike. Can you all hear me all right? I assume that all right. I got a thumbs up from Mike. Yes. Good morning. It's my pleasure to present. And again, this is collaborative work with Gerhard Klemmick and Michael, who just talked, and I think Stephen Snyder is also on the call. Also, Bruce Hare, our system architect here at CNS, is on the call, so feel free to ask technical questions later on. Let me quickly walk you through the work we have been doing, and it is our hope that this relates to what you need in your life, and ultimately that it is going to get adopted by the HUBzero community. So there are a number of presentations that have happened before this one, and they're all linked here. And I made these slides available this morning, and feel free to share them with the larger consortium. One of the more recent posters we had is shown here, and you see very quickly there is a BibTeX upload, download. There are co-authorship networks, there are so-called maps of science, and then there are also geospatial networks of co-authorship. Before we go into details, let me step back and tell you more about the goals, the use cases, the users, the data we are using. So the ultimate goal here is to facilitate a near real-time monitoring of engineering research centers. And this is in support of evaluation purposes, but also in support of strategic decision-making by ERC directors, by those which introduce students to the overall team, or by those which want to connect to engineering research centers. So there are many different purposes in addition to just sheer evaluation, which of course also needs to be done. So here we do data mining and visualization for different stakeholders. Again, it's NSF staff, but also researchers and students, to increase their understanding of temporal dynamics, but also where are people geospatially, topically, that's where the maps of science come in, but also how do these collaboration networks evolve over time, and which ones are more technical, which ones are more on the theory side, which ones have a lot of students, which ones have mostly PIs, etc. So we had different use cases. We had support of day-to-day operations. We had strategic decision-making. And then a major one was also preparing for site visits and also for writing these massive annual reports these engineering research centers are working on and submitting. We had 3 initial power users, Mehmet from ASSIST, Paul Westerhoff from Newt, which is a very new engineering research center, and then Craig Coleman at TAMS. And it would really have not been possible without them because they gave us the needs that these different user groups have. Initially, we tried to use the data that NSF collects from the annual reports. Unfortunately, that data is not useful for what we are aiming to do here. And ultimately, we decided to simply use the bibliography files which are compiled and used for compiling the annual report, which would then mean that once a year you have it all up to date, and then during the year it's up to you to keep it up to date. It also means that anyone who has a bibliography file, for instance, for a book or for a PhD thesis or for any other purpose, can actually use this service because all it takes is to read in that file, and then different types of visualizations can be created. The visualizations you will see is collaboration networks overlaid on a geospatial map, but also overlaid using a force-directed layout algorithm. And you will also see overlays on the UCSD map of science. So the continents are not Europe and Americas, etc., but the continents are math and engineering and social science. The interactive data visualizations can be generated by simply importing data to nanoHUB.org ERC citation. So if you go there, or if I drag my window over there, let's see if I can get it over there, then feel free to actually follow along. We would go to nanoHUB to /ERC citation. And then it tells you, well, please drag a BibTeX file here, and you can then find one on your laptop, in this case here. And in this case, I'm just going to take the one which we have used for Newt, and maybe in the meantime you all can get to that page. But it did not end up in the file which I wanted. All right, here we go. All right, so now we basically drag the BibTeX file over. And as you see, it's a normal .bibtex file, which you might be familiar with if you do LaTeX. If you use EndNote or HUBzero or any of the other bibliography file services, and you can save out BibTeX files, and you get to see all the many different citations that are relevant for Newt. You can then start cleaning that data, but you can also create different types of visualization. And you can have a geospatial map that's overlaid here, and you get to see how new funded PIs and other investigators collaborate across the globe. You will also get to see different interactive data visualizations here. Paul Westerhoff, as the lead PI of this ERC, is very dominant. This is a coupled display where you can click on Paul, and you will get to see his publications in here. So you can click on different authors to see what they publish. You can also go over to a map of science, where again the different areas are medical specialties, biotechnology, and for this particular very young engineering research center, you can also click on a node, and you will get to see all the different publications that exist in this area of research. Going back to the slides, you also have the opportunity to start cleaning out the names. And that is oftentimes needed because some people might have, or there might be different students or staff members or also faculty which create these BibTeX files, and maybe sometimes they mention in middle name, sometimes they don't, and then that has to be unified. Ultimately, you can also enter additional information such as male or female if you want to keep track of this, or lead PI or not. You can start entering geolocation if this is relevant for you, and it's definitely also needed for the geospatial map visualization. You can also add other roles such as staff or postdoc, and sometimes it's really important to understand how these networks are held together by what types of users. You can then download the cleaned BibTeX file so that you never have to do that cleaning again in your life. But you can also request these different types of visualizations you just saw. So again, here you get to see a different co-authorship network, but it's always a coupled display where you have the here the network layout, and then on the right-hand side you have a listing of all the different authors sorted by their number of papers. So here Benton Collin has about 20 papers, and he is the most dominant node in here, and you also see this in the network visualization itself. You can filter labels by node weight so that it's not too cluttered. Sometimes you want to maybe take a screenshot of all of it to just include it in your publication. Actually, some teams have been very smart. They included these visualizations not only in progress reports, but in proposal writing efforts, showcasing that they have the right team on the ground, and all these people have worked together before, and they are all covering the subject matter expertise that is needed for a certain effort. So that's another use of this service. In this case here, you see assist, and this is Mute. So again, very different networks. Just to re-emphasize again, Mute is rather young, so we do expect a smaller collaboration network in the beginning. You have these geospatial maps, which you just also saw in the interactive mode. And you have UCSD Map of Science overlays, where the Map of Science is actually created using Web of Science data and Scopus publication data, and laying it out in a way so that you have different continents of science. And then you can do expertise profiles for different here engineering research centers, but again, you can also overlay your own data. And how it's done is it searches for all the journals in the BibTeX file and uses those to geolocate your respective papers. So there is a mapping in place from journal names to these 554 subdisciplines of science that are aggregated to 13 larger disciplines of science. And so now you can start comparing the different ERCs. So you have Mute, you have TAMS in the lower left, you have Assist in the top right, and you see that they have quite different expertise profiles. And again, Mute, very young, very few overlays. Assist and TAMS, much more dominant in the math and physics areas. These visualizations were used in the ERC annual report. So on the left-hand side, you see the page out of the progress report. And then on the right-hand side, you see the text that was used with the report. And it's interesting to see how they started interpreting those maps and what they thought was important for the site visit team to take away and understand about their respective engineering research center. And again, all these slides are available, so feel free to dig into details or go back to the PIs of those ERCs and really get to know how they used it and if it was useful for them. So here, for instance, you have mute reporting in year 1 and then year 2, so you see a major growth. So growth here is good. They increased definitely the reach they have in terms of the number of experts involved in this effort. For the TAMS report, they actually showed these two visualizations in one report, one for 2014-15 and the other for 2016-17. And again, on the right-hand side, you have the text that came in the official report this visualization. And then again, here in larger, these two visualizations. The visualizations also were used in the slides that were presented at the site visits. And here we did some extra work to have maps that have always the same substrate so that you see these networks grow over time. And that was something that the ERC directors really wanted to show. And again, then you can go back and forth and you can go through different development stages, and you can also start discussing how this team up here maybe should be connected, and yes, in the next time step, it then is connected. But there are also new elements coming into effect down here. Next steps and possible future visualization. We would be interested to discuss today and also later if these visualizations should also be integrated into HUBzero. We are very interested to optimize these visualizations based on user feedback. We have quite a number of projects which are aligned with this particular project. And we also have quite a number of PhD students interested to use the current functionality because it's a wonderful way to do a literature review or a PhD thesis, but to be honest, for any kind of literature study you are interested in doing. And sometimes those are also needed for new proposal development efforts or for progress reports. We also oftentimes provide guidance on how to best get the subset of data relevant for an effort. So I already mentioned Mendeley and HUBzero, which are bibliography services where you can enter a keyword and get all relevant data sets. And then by extracting co-authorship networks, you can identify the key experts, and you might use them for collaborators or for reviews, etc. So there are additional usage scenarios here. And also, ultimately, we are interested to get any additional insights into how you might be using these new visualizations. Before we go over to the discussion, I just wanted to mention two other projects we are currently involved in. One is a project where we correlate IT resource usage here at IU. So you might be familiar with our big red computer, which for a while was one of the biggest supercomputing users at a university campus. And of course, that only lasts a few days. And then somebody else buys a new hardware piece, but also storage units and how they are interlinked with funding. And so these two types of data come out of our production databases, out of IT usage and out of our sponsored research database. And then ultimately using lookup tables, we can interlink funding to publications. And of course, that makes a value argument of how many external dollars came in and how many publications got published because IU invested into IT resources. Another project, we are looking at the interplay of job market demand, courses. I'm on several curriculum committees for data science, undergrad and graduate degrees, but there are other course developments, of course, also here at IU, and science technology development. So as you could imagine, if there is a new blockchain method or a new encryption technology developed in science technology, at some point we might like to teach that in courses. At the same time, there are also new job demands which also push and pull on what kind of courses we should be creating. And so by analyzing this on a large scale using 138 million jobs and more than 70 million science technology publications, and then either just our courses or courses across the nation, plus MOOC online courses, you can do this in a much more data-driven way. And ultimately, resources such as nanoHUB should also correspond and respond to what's happening in science and technology, and potentially also to what jobs are out there and what industry ultimately also needs, to have not a disconnect, but a much tighter coupling between what job market demands exist and what's ultimately known about science and technology development. Now, there's a paper forthcoming on this, which also discusses some of the challenges and why this is especially needed right now when we have a lot of change in STEM knowledge going on all the time. We have more tools coming in, more artificial intelligence. Some of these jobs are going to be replaced very soon by AI. We have much more social skills also needed in engineering jobs. And we have an increasing team size, which doesn't make it easier to actually do this kind of analysis. Ultimately, we do these analyses for students, for teachers like myself, so that I'm aware of new developments, but also ultimately for industry and employers. So we have a number of companies we work with. And ultimately, I and all of you have to figure out how to invest time, money, and compassion into these different areas. There was a recent faculty colloquium on modeling and visualizing science technology development. If you're interested, all the talks are available online, and there's a special PNAS issue forthcoming on these more data-driven approaches for making decisions in science technology development, and ultimately also visualizations that come with it. There's an entire set of books which you might be interested in, and NSF-funded reports. But let's go over to a discussion of what you just saw on the ERC side. And maybe I go back all the way to the poster I showed in the very beginning, because I think it gives you a good overview of the functionality we have right now and how you might like to use it. Thank you all. So I'm happy to take questions.
Thank you, Dr. Warner. Feel free to unmute yourselves and ask questions for the next few minutes here. If you feel more comfortable sending a question through chat, I can read that to the audience as well.
And Erin, do you have a chance to share this with all those which are on the call or beyond that?
Yes, I shared the link for the slides.
Oh, wonderful. Excellent. And again, Stephen and Bruce are also here, so feel free to ask technical questions, like how was it implemented, or what does it really take to make it work on my end.
Yes, this is Carol-san. That's fantastic. So could you talk a little bit about implementation? What services are you using, whether outside HUBzero?
So here it's really, you have a big cache file, which is a bibliography file. And in fact, I could open one and just show you how it looks like. And then ultimately you use these files to provide the data that's needed for these visualizations to be created. And as you saw, in some cases you actually have to add, let me open this in a different browser. In some cases you have to add additional information such as geolocations or roles or gender. So that would be an extra step.
So do you manually add those information into it?
And in some cases, what the ERC leads have been doing is to only add it for the lead PI. For instance, this way we can color code the lead PIs in a different way. Or if there are certain students which are especially relevant for interconnecting it all, you could just give them a student role. Similarly, for the geolocations, we had a staff member here, but you could also use an hourly student, basically just copy over the affiliation information from the papers that we had in a kind of PDF file repository.
Mm-hmm. So these are primarily based on the file. It's not a database where you would, add entries as people upload them.
No, this would be an extra step. We have been doing custom data preparation for those teams which were interested in that. Mm-hmm. And so that is an option, but this was not used here.
Okay,
so here
thank you.
It's really going to Mendeley or HUBzero, or you already have an EndNote file or a BibTeX file, and then the EndNote file you can convert into BibTeX. You basically drag it over that entry field, and it automatically parses it, and then you can do data cleaning, which I think is oftentimes needed, and then it's displayed in these 3 different types of visualization.
Okay, thank you.
Okay, I have a question from chat. From the chat, has this been implemented or tested in some other domain yet? Trying to get a sense of the level of effort to implement this in another domain.
So our PhD students here have been using it in their respective PhD thesis. And so we have one PhD student who works in biotechnology, and so she has to do literature reviews, and we have another PhD student which is working on data visualization literacy. And so he just went to Mendeley, downloaded all the relevant BibTeX references, and that was like 10,000. And so that was a much larger data file than what you would want to compile by hand. And then just you look at these co-authorship networks, you immediately get to see what are the key experts in a certain area. And then you can start looking for their research, and you can look also for highly cited papers if you have that information as well. So here at Indiana University, we have the Web of Science data from 1900 to December 2016. Some of you might also have this kind of access, but we can basically run a database query against that database, get relevant information, then save it as a BibTeX file, and then again upload this to here nanoHUB to do these kind of visualizations.